It's basically just going to be, can you determine whether or not it's a function? And explain is the important thing for you to get to a level 4. So on the actual mastery, it'll be, so like if you just say yes or no, that'll get you like a 1 or a 2, depending on whether you get it right or not. If you can actually explain why it's a function. So remember, you will never have a level 4 question or level 3 that just says, give me yes or no. You need to be able to tell me why, so that's pretty important. And then 4 would be something that's a little bit more challenging. We'll talk about examples of level 4 questions later. All right, so I put on the front page of your notebook. So this is literally on page 2. I see it's loading slow. It's all right. I'm recording this in case you need to go back, or I can upload a picture of it if we need to. I don't want you to sweat over your stuff running slow, so it's okay. I'll find ways if you need it. So the official textbook definition, we have already covered that each individual x value has one element in the, or one y value basically associated with it. What I like to say in normal people language, in my opinion, I like to say if you have the same x's, hold on. So in normal prefer, instead of the textbook definition, because it just makes sense to me. So if you have the same x's, you must have the same y value. I feel like that's a little bit more straightforward. So it's okay, as we saw in the auction, if your x's repeat, that's cool, but they better have the same y values to go with it. A good real life example, because you know that we also call, we've got to have 18 names for the same crap, right? X is also called domain. We also call the X the independent variable. We also call the X input. When you were in 6th grade, you probably heard the word input. Okay, so when you're typing on your keyboard, if I hit the X button, that's my input. That's what I'm typing into the computer, right? I can hit the X button multiple times and it's still functioning correctly as long as the output, the computer, gives me a letter X. So you can hit the same input over and over and over again and get the same, but just make sure you get the same Y value out. So rather than have you guys have to write down a bunch of stuff, I just had you guys, I wrote it out here for you, kind of the steps. So you just need to look at your X. So I kind of wrote that out for you while we're trying to get my screen back up here. So it says, I tried looking for some Apple TVs that weren't as expensive. And
good luck with that.
I know, because I really miss. Thanks for your patience, friends, with my technical difficulties. Okay, so rather than have you type out the steps, I just kind of wrote them. So in every single time, if you want to see whether or not it's a function, you'll just look at your X values. If an X is repeated, it can be a function. They just have to have the same Y value to go with them. But if it's matched with a different Y value, it is not a function. So how about my first example, my first set of ordered pairs? I would color code this too if I were you. So we have the same X values, which is okay, as long as we have the same Y values to go with them. Is that what we have? No. Okay, so an example of this might be, so we have different Y's to go with it. So an example might be, I'm a huge fan of Diet Mountain Dew. You probably haven't seen me drink it a lot because you guys see me in the morning. And so I go to the Coke machine, right? The input is the Diet Mountain Dew button that I'm hitting. If I hit the Diet Mountain Dew button multiple times a day, which I do, what better be the output if that thing is functioning correctly? I should be getting Diet Mountain Dew every time. So if I hit it once and I get a Diet Mountain Dew, but then I hit the same input again and I get a Coke, different output, even though I hit the same button, something's wrong, right? It's not, somebody's in trouble. Somebody's not functioning correctly, okay? So that's kind of a real life example of why a function works the way it is. If you hit the same input, the same thing better happen, better come out. So for the same reason, let's look at, or for a different reason, let's look at the next one. So my next set of ordered pairs, so the ordered pairs on the right, are those going to be a function? The ordered pairs on the right. Yes, they're a function. I do have the same x's. However, we also have the same y value. So this one was a no, but this one, the one on the right, friends, is going to be a yes. Because even though you've got the same x's, you've got the same y's to go with it. So that one is going to be a yes. Oh, and we've got our yes. How about the mapping? Remember, the mapping is the one that's got the little ovals. Although the mapping, sometimes instead of it being that oval shape, sometimes they're also square, rectangular, just so you know they don't have to be a circle. So is that one a function or no? No, why not?
Because there's two different x values and they have the same y value.
Correct. That 7 appears twice, and it has 2 different y values going with it. So you are correct, dear. That is also a hard no. And last but not least, how about in my table? Is that a yes or a no?
No.
It's a, so we got 2 3s, which is okay, as long as they got the same y value. No, right. All right, so check to see if you have any x's that are repeated. If you do have x's that are repeated, that's cool. It can still be a function as long as the same y values are repeated as well. If not, it is a hard no. And then you didn't need to type this. I just wrote it out for you here down at the bottom. If no x's are repeated, you automatically assume it's a function. The example that I used to give is like innocent until proven guilty. You're going to assume it's a function. What proves it's not a function is having the same x values with different y values. But if you don't have that proof, you automatically assume it's a function. Now, what has a tendency to get kids like you guys that are really bright and have good number sense is sometimes you'll look at a set of ordered pairs and you'll be like, there's no pattern to it. That doesn't make sense. It couldn't be a function. Sometimes y'all try to think a little too hard about trying to come up with a pattern to explain the connection between the two. It's just straight up, though, if they don't repeat, if your x values don't repeat, automatically assume it's a function. So in our cases here, these are all examples down at the bottom where all your x's are different. Don't ignore that one. I realized I forgot to add the y coordinate to go with that 9. But in all those cases, your x's are different, so you just assume it's a function. Okay, so the last thing, because this goes to, somebody asked a great question about this earlier. Because they're like, well, is it the same in reverse? If you've got x's that aren't repeated, but the y's are all repeated, can that be a function? The answer is yes. This is a function. Let me give you a real life example of why. Let's say that I've decided I'm going to Netflix all day. I'm not going to do any work. Okay? So x represents the number of minutes I'm laying on the couch. If I'm sitting on the couch, am I going out for a run at the same time? No. Okay, so if x represents the number of minutes I'm on the couch and y represents the number of miles I've run, well, I've been sitting on the couch for 10 minutes. How many miles have I run so far? Nothing. Okay? In my second one, you guys, at least you guys can see it. I've been sitting on the couch for 20 minutes. How many miles have I run? Still nothing, right? So if you're sitting still, that's a great real life example of when you can have the same y value, even though your x values are different. That's totally possible. Sitting still is a perfect example of that. The y value will stay the same, even though all your x values are different. Okay, is anybody not okay? You guys picked up on the fact that if you see 2 coordinates that are stacked on top of each other, those are not going to be a function because they've got the same x. So for example, right here and right here, they have the same x value because they're lined up and they're at the same x. But since this one is up here and that one is down there, they have a different y value. There is actually a math term for this, and it is called the vertical line test. So what that means is if you can draw a vertical line anywhere through a relation and you hit it in more than one spot, this does what we call, there's a special term for this, we say it fails the vertical line test. So fails the vertical line test. That means I was able to draw a vertical line through it, and I hit it in more than one spot. So when that happens, this is not a function. So that's a messy no, but that is a no. That is what we call failing the vertical line test. You can draw a vertical line through it, and it doesn't matter that you can draw a vertical line. Some people get confused about this. Some people will say, oh, okay, well, that line right there, it only hit it once, so it must be a function. If you can draw a vertical line anywhere in it and hit it more than one place, it is not a function, okay? So looking at the other example, that example that's got a 4 next to it, even though it's not example number 4. If I draw a vertical line through this, is it going to hit it in more than one place anywhere? No. Okay, so this one is an example of what we say is passing. The VLT is what I say for short, vertical line test. So this is a yes, it's a function. So no, because that one fails the vertical line test. That one's a yes, because you can draw a vertical line through it, and it passes the vertical line test. And while you're writing that, all of the real life examples that we've done so far, this is another way you can kind of tell whether it's a function or not. Every graph that represents a real life situation will pass the vertical line test. Like notice back when we were matching up the graphs with real life situations, you don't ever have an example of like one with a coordinate that's stacked on top of each other. And here's why. Let's say I'm drawing myself a graph. I'm out for a walk. This represents the number of minutes that I'm walking. This is how many miles I've walked. If this were an example of a graph, that would be saying that I'm like 1 mile away and 4 miles away at the same time. Can you be 2 places at once? No. So that's why this is not a function, and why failing the vertical line test means it's not going to be a function. Because if this were your number of minutes you've been walking, and that's your number of miles, because you know time usually always goes on the x-axis. You can't be in 2 places at once. So that is why every real life situation will always be a function. So that's another way to think about it. If you can think of a real life situation that would represent that graph, it's always going to be a function, because if it can happen in real life, it's definitely a function.